Okay, what I want to do now is try and put together several of the concepts that we've worked with so far to talk about what is the whole process that happens by which a web page ends up displaying something within your browser. So what does that look like? When you first open your browser on your computer, what you're doing is you're running a program that exists on your local computer. So the program is something like Chrome or Firefox, Safari, Internet Explorer, one of many different browser programs that lives on your local machine. So it exists on your hard drive. When you start that program by, however you start your program, double-clicking on the icon or finding it from a menu or something like that, what happens is your operating system is loading that program from your hard drive into its working memory and then starting to execute that program locally. So at that point, no internet resources have been required. When your browser first starts, it will open a window. It'll open a window on your local display, and your display and the browser are all just locally hosted. It hasn't had to go out to the network necessarily. Now, it may have gone out to the network to check to make sure that it had the most recent version. Maybe there's some kind of advertising that it required from the internet. But basic requirement did not require the internet at that point. Now, you as a user have your browser window open, and you go into the address bar and you type in an address, for example, www.ics.uci.edu. Now, when you hit enter on that browser window, your browser starts to undertake a number of interactions with the internet in order to get the HTML file that it needs to render in its browser window from the internet. The first thing that it needs to do is it needs to know where on the internet does it go to find www.ics.uci.edu. And in order to solve that, we have to execute the DNS or domain name service lookup protocol. And so the browser is first going to see within its own program, hey, have I seen this address recently? Because what I need to do is I need to translate this from www.ics.uci.edu into an IP address that consists of, if it's IPv4, 4 different sets of numbers. So the first thing that it does at this point is look in its DNS cache to see if it has ever translated that recently, if it's recently translated it. Let's say it hasn't. So then what it's going to do, it's going to ask for that translation from the operating system. The operating system is going to check to see whether in its hosts file, depending on your operating system, that can be at different locations, whether there's a manual translation that's been put into your computer to translate that domain name into an IP address. If it's not present, then what the operating system is going to do is it's going to look within its DNS cache and say, hey, has any program on this computer recently tried to look up something from www.ics.uci.edu? Because if it has, then I have a record of that translation already, and I'm going to use that. So that would be a cache hit in the operating system level. If that's not present, then the operating system will say, well, I can't answer this query, so I'm going to have to go out to the internet to get this query solved. And so it's going to ask the ISP to answer that for you, whoever you're connected to. And the internet service provider is going to check to see whether or not, through the domain name service system, it's going to check to see whether or not it has seen that request recently, not just from your computer, but from any of the computers which it hosts. So you can see at each level, we're encompassing a broader and broader group, a pool of possible users that could have requested this translation. If your ISP cannot find that translation for you, then it probably is going to go out and go to the definitive source. It's going to go to the overarching domain name service system, and it will request it from one of the top-level domain names. And that requires the process that we looked at in our DNS lecture of asking the top level, who will tell us where edu is hosted, which will tell us where UCI is hosted. And so if we have to go to the top level because all of our cache is missed, we'll get back the definitive answer of what the IP address is. That will get returned to our internet service provider, who will say, oh, okay, well, I got the definitive translation. I'm going to keep that in my cache for a little bit. So it puts it into its cache. Then your internet service provider passes it back to your operating system. Your operating system says, thanks ISP for that translation. I'm going to keep a copy of that translation in case someone else asks in a little bit. So it adds it to its cache. The operating system then sends it back to the browser, and the browser keeps a copy of it. And then the browser uses that translation. Now it knows where on the internet it can find the information that you're looking for. And so now it executes a second request. This request is not for the translation, but this is the request for the actual HTML document. And so, with the knowledge of the IP address and with the knowledge of the domain name, it sends that request out using the using whatever protocol you've specified in your URL. Typically, it's going to be HTTP or HTTPS. So it'll put that request out on the internet. And your ISP will pass that request to another computer, which will pass it to another computer and another computer. A chain of computers, that's where the internet gets its power from. All these computers connected together that are passing requests along one at a time from some source to some destination. Now there's a whole other set of protocols for how those computers understand which way to pass the data packet. That's not relevant for our discussion here. It's sufficient to know that when our browser puts that request onto the internet is going to route it to the destination that we've specified with our IP address. When the computer on the other side of that chain, the one that's responsible for handling requests for that IP address, receives the request, it's going to look at the domain name that was requested and the resource that was requested from it. For example, the index.html file or whatever file or resource you've requested, and a program on the remote website is going to evaluate it. That program on the remote website is called a web server. Typical web servers are programs like Apache. Apache has a web server. Other web servers include ones by Microsoft. There's some lightweight servers that are used, like Nginx. What other web servers? PHP can actually run its own web server as well, and there are a lot of little web servers that can be run just in a lot of programs that can be executed. So there's a lot of different programs that can possibly act as a web server, just like there are a lot of different programs that can act as a web browser. Whichever web server it is that's running on that remote client, it receives that HTTP request on a particular port. For example, port 80 for HTTP or 443 for HTTPS, and it then goes and tries to resolve that. If the request was simply for a file that exists on the hard drive, then the web server will go to the web server's hard drive and it will grab the HTML document and it will send it back over the internet. If it wasn't just if that web server is not designed to just deliver files, it may need to construct the HTML text on the fly. So it may have a program that is going to decide, based on who made the request, what content should be put into that HTML document. So a company like Amazon.com, for example, is going to fill out that HTML document with an advertisement and some recommended products and maybe an order history, maybe some information that you asked for last time you came to this website. If that's the case, then the web server is actually going to use a whole bunch of other computers that it has at its disposal to construct the HTML that it's going to send back to the browser. Whatever it does, though, the web server is going to return an HTML document that has the tags and the tree structure, attributes, content, all that stuff. It's going to travel back across the internet, probably in a path very similar to the path that it took, but not necessarily the same. And then your web browser, who is waiting for your web server to send a response back, will receive that text document. It will then analyze that text document, assuming that it's HTML, and will create a tree structure internally in the browser. Using that tree structure, it will begin to render, create a visual representation of the HTML, of what the HTML demonstrated. Now, we've seen that there are some tags, for example, the image tag that might be in an HTML document that references other resources on the internet. So an image tag, for example, often, most of the time actually, references other files, which are the image files themselves. And so just that first HTML document that's returned may not be all the information that's necessary for your browser to draw the picture of the web page in the window. It may need to go out and get many other resources. And so in previous examples, we've seen how some websites require 40 resources or 70 resources or hundreds of resources. Those resources include images. They may include information about how to aesthetically draw your HTML diagram, your HTML document, for example, using CSS style sheets. It may include images that need to be requested. It may include fonts. It may include JavaScript. It may include code that it needs to go out and get. So your browser then, from that one initial request that a user has put in, makes one initial request to a web server, and when it gets the primary HTML document back, it then generates a whole bunch of other requests to get all the little bits that it needs to fill in on the client side in order to draw the document faithfully the way the web server asked the browser to. Then the web browser presents to the user the rendering of the document as it came in. Part of that rendering includes running JavaScript code, and so it may not be that what is drawn in the web browser is just a static image. It may be an image that has animations. It may be reactive or interactive to the way the user interacts with it. But all of that is being described and being controlled by the HTML document that was originally sent back. So at that point, the web browser's job is done, and it waits for the user to interact with the page that it's drawn. And until that happens, it's going to just do nothing other than render the page as it was delivered. So that's basically the end-to-end story about how the web browser gets content and delivers it back. And that puts together many of the different pieces that we've seen up until this point in our tutorials. Thanks for your attention.